Topic 13 also has the economic order quantity. So this is under 13.6 tools, the economic order quantity. So there's a lot of factors that go into this. So we'll use the demand, order cost, the value of the item, holding costs, and a couple other factors. So when we factor all this in, we do take some assumptions, and we'll go over those as we go through these. So the nature and assumptions of the basic economic order quantity model is that you have pretty consistent fixed order quantity here. So you're taking the average of that. So, and then we also have the instant receipts of orders. So as soon as that order is placed, you receive it. So it's just like it's showing up in your dock and it's instantly in your inventory system, but it hasn't been put on shelves yet. This is a little unrealistic, but for our purposes, this is how we're going to go at it. And this also shows that there's no shortages. So whenever we order something, it arrives in a relatively straightforward period of time. So we do have some inventory assumptions. So we're just looking at one product and one market. And we know the actual demand. You know, we know that we're selling 100 units, or are we selling 1,000 units or 1,000,000 units? And that demand is constant. So we don't have the fluctuations. So, which is pretty unrealistic, but for our purposes, this is an easy way to figure this thing out. And then orders are received instantaneously. There is no lead time. There's no transportation from your vendor to yourself. It's instant. So we have some variables that we're going to use in this. So we have the annual demand, which will be represented by a capital D, and that will be in units, 100, 200, 300 units. So in our unit value, how much is each one of those units worth? So that's going to be the lowercase c, and it's always going to be in a dollar figure. Then we have our inventory holding costs. We have two variables here. We have a lowercase I, which is a percentage, and then we have a lowercase h, which is a dollar amount. Then we have our order cost, which will be represented by a capital K and is always in a dollar figure. And then we have our order quantity, which is a capital Q, Q for quantity. That's going to be a number of units. So we first have to figure out our annual inventory holding costs. So as you can see here, annual holding costs are going to be our average inventory times the cost to hold it. So average inventory would be our quantity divided by 2. So we have the top end and the bottom end. So we either have the full amount or no amount. So we take the middle ground, the average. And then we multiply that by our holding cost, which is H. So we have Q for quantity divided by 2 multiplied by H, which is our holding cost, which is the actual dollar amount of the holding costs. And that's represented as we have more quantity from left to right. Our annual holding costs are increasing over that. So we have our annual ordering costs. So as you can see, the more we order, the better price we're going to get from this chart. So our annual order cost is the demand divided by the quantity. And then we're going to multiply that by the order cost. So you can see left to right, it's decreasing. So think, you're ordering 1, but if you're going to use 10, like go to Sam's Club and you're buying a larger quantity, it's usually smaller per unit. So if you're buying ketchup, a 64-ounce bottle of ketchup is going to cost less than a 16-ounce that you might buy at Walmart. So now we put all these onto one chart here, and we also add a total cost, which is just essentially adding the holding cost and the order costs. Then we have the formula here. We're putting them both together. So we have our quantity divided by 2 multiplied by H for our annual holding costs, and then our demand over quantity multiplied by order cost for our annual order costs. So then our green line, like I said, is the combination of the two, just adding the two numbers together, and you can see the overall cost of this. But notice how that line dips and then starts to go back up. So keep an eye on that. So there's a trade-off. At what point do we actually lose the benefit of having an economic order quantity? Yes, we might order 300 because that's an easy number to put on our shelves. But as we can see here, the line is just a little bit lower than 550 units, which would be our economic order quantity, which would be our least amount of total costs. You see the intersection of inventory holding costs and our order costs. So that's the perfect amount using the basic economic order quantity model. So here is the actual formula for the economic order quantity. So we have quantity, which we'll actually end up with knowing, equals the square root of 2 times demand times order cost divided by our holding cost in dollars. That's what the lowercase h is. So if we can optimize this by getting the best Q, which is our best quantity, that would actually save us money. And we'll actually show you a example of this. So here we have some parameters here. So our demand is 125 units per week. And then we have K, our order cost, is $75 per order. So we have I. Now remember, that's the percent of our holding cost. So it's 15% per year per dollar of inventory. Then we have our lowercase c, which is the unit value. For each unit, it costs $40. Then we have h. So we have $6 per unit per year. All right, so if we start plugging these numbers in, you can see the Q star, the square root of 2 capital D capital K divided by lowercase h. So the next section here, we have 2, and then D, since we're doing an annual one here, it's 125 times 52. So when you look at D, it says units per week, but we need an annual, so we need to multiply that by 52 weeks. And then we're going to multiply that by 75, the overall there, by 75, because that's how much it costs per order to place. And then we're going to divide that, and you see it has the 0.15 for I times 40. So that's the per unit. So 15% of $40 is 6, which is the H. So you're taking that percentage and finding out the dollar value. So when you do the math, you're going to have the square root of 975,000 divided by 6, which equals 403.11, but you can't have 0.11 of a unit, right? So we round up. So we have 404. So when we look at our old quantity that we used to order, and we plug it into the two formulas to figure out where the lines were on the graph, we come up with $2,525 when we ordered 300 units at a time. Now, when we did the economic order quantity, and we came up with 404, when you do the math, it comes up to 2,418. So there's a difference there. So when we ordered more, we actually saved money. So by reducing our order cost, we can buy smaller quantities. So we can really change with the market. So hopefully this will get there where we can figure out, if there was no order cost, we could really buy the smaller quantities.